Hi, I'm Ryan.
I'm Nathan.
I'm Taylor.
I'm Hiram.
And I'm Cody. And we're going to be doing the interactive education application. I'm going to start by giving some preface to how we got this idea and just our brainstorming behind the whole thing. Whenever we met as a team for the first couple weeks, we know we wanted to do something within education. We really wanted to try to give back to the university, and specifically computer science department itself. As students, we know that there's like a lot of things that could change, and kind of everyone just always talks about those changes and what they might want to see, but we never really got any concrete ideas. And then we went to lecture one time, and Dr. Musser had an idea that he had been working with on the side, but it hadn't had a lot of time to go fully in depth with it. So we met with him, and his statement was that kind of education within computer science has not really evolved along with how much technology has evolved, and like the type of languages and the applications and skills set that we have evolved with in the field itself. And so we wanted to make those match. And so typically what you see right now is a student will go to lecture, they'll sit there statically, they'll kind of be talked at, and they may or may not be listening the whole time. Then they'll go to lab, and they either know it on their own, they learn something in class, or they will be so confused and they'll just Google their way through the lab. We want to change that, and that's what our purpose of our project is. So we want to create a supplemental tool that helps students better understand code from the base. This can go for entry students, even people outside of computer science that might want to get interested and see if this is right for them, or upper level students. Our biggest thing is we want to try to help people that don't just understand by going to lecture, don't just understand by just reading static text. So we're going to use different mediums such as audio, text, and conversation. Audio meaning that within our web application, we're going to be able to have a professor take either a snippet of code or a full set of code, like a program, and add in either line by line or give a overarching audio demonstration of what each part does. And then also they can go back in and add text into those, like as a single character, so you can say this portion does exactly what this is doing. Then the final part that we discussed, we think it would be a good idea to have produce community like within students, and not just make this isolated like some students in the computer science field is, to have a commenting and conversation system. So not only can the teacher and the teaching assistants create those audio files and those text files, but we're also going to have like a section where students can come in and write text of their own, ask questions, answer other questions, and so that will be another way. To get into the more specifics of the program, I'm going to hand it over to Taylor.
So for the user interface, we have a few different sections here that I'm going to talk about. First, and probably the main topic, is the code examples. So here you can, professors or admins, we kind of use those terms interchangeably, but they can go in, they can post this section of code or an entire program. They can go in there, post this, and then they are the administrator to that code section. So they can do different access controls to that. So if they want to have it password protected, say if it was for a class, something like that, they have different access controls on that. So what they'll do is they'll go in, they'll sign in, they'll have the part where they actually input the code to. They're going to submit this form, and then it's going to be posted for different users to see. And then for highlighting, so a big problem with posting code online or anything like that, you post it, it's all usually black, it's hard to see, it's hard to read. So we're going to use the Highlight.js. It's a JavaScript library. It supports 112 languages, and with that it does automatic language detection. So you can go in there, it automatically is going to color it for the user to see. So the teacher or admin, they don't have to go in there and actually highlight this to their syntax, how they want to do it, and then they can do that. So then with the audio, like Cody said, we want to have audio so the teacher can explain the code more, can go more into depth than just the code can show. So for that, we're going to use the Media Stream Recorder. It's another JavaScript library that they can record right into the web application. We're going to store the audio on the web server, and then the file is going to be stored in the database. So we can store it right on there, and then not only with audio with the code blocks, but also with the other comments that can be put on there. So if they don't want to do audio for whatever reason, they don't have a microphone or something, they can just put comments on there to help better explain it. So then if there are audio or if there's comments, that's going to be, the user will be able to know that by, we're either going to highlight it, or there's going to be a way that the user knows that, this portion of code has an audio block, has audio associated with the code block, so they can click on it, they can listen to the audio and help get a better understanding. For comments, you can have comments on the code blocks for the public code blocks or the private code blocks as well. For the public, that'll be just kind of the user source where they can kind of talk about the different things pertaining to the code or different questions they have. And then for the private, the admin will have to allow those comments, so if they don't want someone giving the answer or something like that, they can reject the comments that are associated with that. And then the different views, so we'll have three views. We have the restricted view, the non-restricted view, and then the admin view. Kind of what I talked about before, the restricted view is going to be the view that if there is an admin that created a code block that doesn't want it to be public, they can either do a password, or they can restrict it in some way. The non-restricted view is just going to be the public. Any user can go view this, can write comments on it. And then the admin view, the last view, is going to be where they're going to do, they're going to manage their code blocks, where they can create, they can update, they can delete, they can do with users that are associated with code blocks, anything like that. And then for the compiling portion, I'm going to hand it over to Ryan.
Right, so I was responsible for determining how we really wanted to implement our online compiler. Our goal with the compiler is to have a user interface on our web app where somebody can go in and submit code, and then the code will be compiled and ran, and then the user will be able to see the output from the code. And ultimately, we really only had two ways to implement this. We could code it all ourselves, or we could find an API which did a lot of the work for us. And luckily, we found Sphere Engine, which suits all the needs that we have. There are a few minor and manageable constraints, which I'll get to in a second, but we chose Sphere Engine for two reasons. One, because it supports over 50 different programming languages, and although we probably won't need all 50, it also covers the most common ones that you would use in education, such as Java, C, C#, etc. And then the last reason why we chose it was because the documentation on Sphere Engine is really, really good. It's simple, easy to read, easy to learn, and they have plenty of examples that you can use for your own code. Some of the constraints that I had mentioned, Sphere Engine requires the programs that it compiles to be relatively simple, and by that I mean they have certain specific things that they have to have the code adhere to, such as the source code cannot exceed more than 64 kilobytes, execution time of the program can't exceed 5 seconds, you can't communicate with external servers, so network communications aren't allowed in the programs. But another constraint we had was we're currently using the free version of Sphere Engine, which limits us to 1,000 submissions per month. And that's fine for our testing and development, but for a production server, it'd be more appropriate to pay for the premium version of the Sphere Engine. One last thing to note about the Sphere Engine is that the only way to communicate it is via SOAP requests over HTTP, which leads me into this slide. So although we have an API which will handle all the compiling for us, we have to have our own program that we write, which will actually handle the network communications and the response creation. So its main purpose is creating SOAP messages and interpreting server responses. So we get everything that we need to create the SOAP message from the user interface, submitted through HTML forms, and we need stuff like the language that the user wants to compile in, any command line arguments you might have, the source code itself, obviously. So it uses all that to dynamically create the SOAP message, which is then sent to the server. The more complicated part is interpreting the server responses, because that's responsible for determining whether or not the response is HTTP error, or if it connected to the Sphere Engine server, what kind of SOAP response it got back. There's quite a few different kinds of responses that we're expecting to receive, so it has to be able to determine that and then produce meaningful output for the user, all through the UI that Taylor just talked about. And now Hiram is going to talk about our database.
Now, the major components of the application that will be covered in the database will be the user accounts, institution courses, tutorials, and access control. Now, for every user in the application will be required to register for an account. This will be provided by the UI. It will be a simple registration form that will take their email, and this email will need to be from their institution that they're in, and the password will be hashed and salted, and then we'll store that into the database. In order to access the courses, the institution courses, they'll only be required to be the person to access this will be required to be an instructor, and the instructor will be upgraded by an admin of the institution. These instructors will now have the capability to create sections which they can upload their tutorials to, and then other users can now follow those sections and see what the tutorials are. Now, the sections can either be opened or closed. Opened sections will mean that anyone can basically just go follow it without having to request for acceptance into the section, and the closed sections will only the instructor can add the users. Now, in the aspect of audio, storing the audio sync tutorials, basically when the user uploads their code, they will have the option to break it down into tiny code blocks, and these code blocks will each one of them will be associated with an audio file if they choose to do that. And the way that we're going to keep track of this is by the order is by the attribute block num, which is in the table of code blocks, and this will keep track of how the code blocks are in order. And also, they will also have the option to upload files for users to download.
And then I'm going to talk a little bit more about our team. So it's a group project, so we all have team roles, but we're all going to be also working on every single portion of the thing. So Cody and Taylor aren't going to be the only one doing the UI design. We're all going to be part of that, and we're all going to have a little bit of say in what gets put in there. And this way we all know what we're talking about. Not one person gets stuck with everything. If somebody has problems, they'll be able to get help from other people in the group, and that they're not just stuck on it all by themselves. But we did create team roles for the purpose of so that there's somebody as a leader for each section of the project. That way nothing falls behind and nothing gets forgotten. We all have a responsibility that we're supposed to be taking care of. So Cody and Taylor are going to be the section leaders for UI design and implementation. Hiram will be working on the database, and Ryan and I will be doing the compiler. And then also for the web application development, which is just like filling in the blanks for the application, sort of stuff that doesn't fall into any of these categories, like the common team forum and whatnot, will be done by Cody, myself, and Taylor. And then we chose to do the agile development methodology, but we're going to modify it a little bit to better suit ourselves. We're going to do it iterative, so we're going to come up with a problem, design, implement, and test, and then continue doing that on every single problem that arises. For the Scrum, we're not going to meet every day, most likely, because we all have other stuff that we're doing, but we're going to meet at least twice a week, and then when it comes down to it, we'll probably end up meeting a lot more than that. And these scrums, we'll just talk about what we're doing, what we're currently working on, if we have any questions about what we're doing, and if we need help. And this is where we'll sort of come together as a group. And then we'll have sprints. They'll vary in length depending on what you're doing, depending on how much work you have and whatnot. And then we'll have a sprint master who's going to sort of run these scrum meetings and come up with a plan. And we're going to alternate on who does this. That way we all can get experience with being a leader and taking part of this, because we're also trying to learn in this as well. And a couple of the reasons we chose the agile development over other ones is because it's what a lot of companies are currently doing right now. So it's going to give us some more practice with it because it's very important and popular. And then it's also, we've all done it before in previous courses, so we all have some idea of what we're doing. And it's also another good way to keep us on track and schedule of what we're supposed to be doing.
And then I'm going to speak a little bit on the budget. So this is just a breakdown of the monthly budget, just kind of estimates. If we were in Columbia, Missouri, there's 5 of us on the development team. So that first box is just for one individual. So it'd be, we didn't do the math correctly on the slide, I did not, but it's $11,946, not including 4 other salaries. But that's per month, and then go to the next slide. And then one-time expenditures, so like hardware, so all of our machines that we need, the software, so like the Sphere engine, not including the monthly fees, and then like office supplies, we listed all that out, and that gives a total of about $235,000 to complete this project within 6 months if we were given a deadline from January to May.
All right, so like I said, we're the interactive education application. We just really want to create an application that's going to help students, whether it be students here, whether it be students that are just learning how to code and trying to see if computer science is what they want to get into. So we're going to create an application where they can learn about code, they can submit some smaller programs, get it compiled, get results back. So it's just a total interactive way to help them all learn.